And all attendees are expected to behave professionally during this webinar. Please use the QA to ask questions. This session is 60 minutes long, and we will aim to leave 10 minutes for additional questions at the end of the presentation. So I'm Sonia Barbosa, and I manage the Harvard Dataverse Repository, and I manage the Murray Archive, and I work with the Dataverse project team here at IQSS at Harvard University. We have Gustavo Durand, who's our technical lead and architect of Dataverse, and Amber Leahey is the service director at Borealis, the Canadian Dataverse Repository. And I'm not going to try to pronounce that in French, Amber. And Scholars Portal, University of Toronto Libraries. So welcome. Today, our agenda will cover an introduction to Dataverse, briefly the data management principles and how Dataverse supports these. We'll discuss file handling and deposit, permissions and access, overview of file handling features, management of various data types, file versioning, file and external tools and integrations. And we're going to spotlight analysis survey data using Data Explorer version 2, and then we'll have some resources for you. Please note that this webinar is a continuation of previous webinars, so we won't be covering the Dataverse project, other details of the Dataverse project. This is specifically on data handling. So just a brief introduction of the Dataverse software. It's an open source repository software designed to help researchers and organizations to manage, publish, share, and preserve their data. It provides a robust and user-friendly environment for data management, ensuring that the valuable research data is organized, accessible, and maintained over time. Dataverse promotes open science by facilitating data sharing and collaboration within the research community. There are 105 installations of the software that are used for data sharing around the world. So briefly talking about the data management principles, which takes into consideration data management, metadata management, data ownership, backup and recovery, access and retrieval, data documentation. But the way that Dataverse supports these is they help users organize the data by providing repository access, folder support, and storage for different types of data cases and associated metadata. It provides support for proper metadata and documentation that are essential for understanding and reusing data. It provides and encourages users to provide comprehensive metadata to describe their data sets at the study level and the file level. And it promotes the data sharing by allowing users to publish data sets, assign persistent identifiers like DOIs, and specify access rights. It also offers security for controlling access to data through permissions and embargoes to ensure data security and compliance with privacy regulation. And Dataverse supports long-term data preservation, ensuring that data remains accessible and usable over time. I'll be talking about file handling and deposits in Dataverse. So there are a few things to know about beginning your file sharing on Dataverse. First, note what you're going to share. It's research projects, scientific data outputs, normally outside of articles. Harvard Dataverse in particular is the example. The repository is the Harvard repository that I'm going to mention a lot today. We specifically don't support documentation without data at all. There are other repositories that do that. So we're expecting that you're going to share data and scientific outputs that are reusable. You want to consider organizing your files for deposit, the file types and formats that you're going to share, the file upload options that are available in Harvard repository, file sizes, and file level metadata support there that are available, such as file naming, descriptions, file level tags, and file level edits. So by following best practices, you can make your data files more accessible, understandable, and valuable to others who may need to work with your data. So file types and formats. What you see here are open data formats and structures that are openly documented and free from proprietary restrictions. They're designed to be easily accessible and readable by anyone. These formats are typically non-proprietary, meaning they are not controlled by a single company. They often have open standards, specifications, or documentation available to the public. And these formats are crucial for data sharing, interoperability, and long-term accessibility. Tabular data formats specifically are structured data formats that organize data into rows and columns, making them easy to read, to manipulate, to analyze. They're commonly used for various types of data, including spreadsheets, databases, and datasets. And we will talk later about the special functionalities and ingest that we offer for those files in the Dataverse. So with the Dataverse software, all files must be uploaded to an existing dataset page. That's the image you see in the beginning of the schematic here. Files can't exist outside of a dataset. That dataset has all your metadata describing the study. And steps to organizing your files for deposit include the following, and their examples are from the data shared on the Harvard repository. So you want to consider folder structure, file names, access control, and licensing that would be used, the data cleaning that you've done. All of these things need to be determined ahead of time before you start sharing data. With these decisions, the Dataverse features for handling will organize and present files for findability, accessibility, interoperability, and reuse. So I'm just giving you some examples so that you can see that people organize their content into folders in order to use the folder hierarchy preservation for replication data sets. They determined their access restriction ahead of time. Here's what's available in the Dataverse, and in particular in the Harvard Dataverse: public, restricted, embargoed, then public, embargoed, then restricted. And then we also have support for zip files that are uploaded as compressed files, but it's a zip previewer, and somebody's going to talk about that later. Make sure you use consistent file naming. Ensure your security and privacy decisions ahead of time. Test what you've shared once you do put files up. Make sure they open and they download as expected. You're always going to be required to provide contact information for people that are using your data. So size options, file size and upload options and examples that are available. These file limitations specified here are for the Harvard Dataverse Repository. There are 105 repositories. They all have their own policies about what they support. So know the policy of the repository that you plan to share your data in terms of the file type supported. File size is accommodated, and the limits on the file sizes to utilize some features. So for the Harvard Dataverse, we've talked about the limits here for the tabular ingest files that you're going to learn about, and the size limitations for what will be ingested and acted upon by the tool. The total project sizes are listed here for Harvard and non-Harvard and paid available storage options that are available. And then our policies for Harvard Dataverse in particular: no identifiable data, copyright adherence, no protected password files, and the default terms for your files and your data sets are CC0, and you can change that. But these are just some of the options for file uploads. Here is the screen for the file upload. You can select files to upload in batch, drag and drop files, upload files from Dropbox, and then there are a number of APIs, and I've included all of them here, but there's an API that will let you also set up for file upload to the Dataverse. So the other thing to consider during the file upload is metadata considerations. These are things that you prepare ahead of time. Again, metadata is going to be extracted from tabular and other files with tabular ingest features. So if you have a tabular file, know that it's going to pull out the number of variables and the number of cases. We have these things called file tags that you'll be able to add to your data. So think ahead in time about your file and what kind of tags you're going to need to describe them. There are additional metadata, they're searchable, that you may want to include. Note that if you have a file, you're able to add a description, and you should, to the file. This is a PDF file, but you can add specific file level terms directly to your file descriptions, as in this example that's put here where it says data cannot be used in any publication. That's for that specific file out of like 20 files in this data set. So plan to populate additional metadata for the description, edit the file names as needed, and add the tags. So just some additional high-level support that we do for files. There's computational workflow and file support. So as you can see, we support file path and folders, the tags, and so you can tag something as a workflow, not just a code, data, or documentation. There's also metadata in the data set that will allow you to describe what you're putting in for computational workflow. There is LLMs for exploration of data. This is our newest chatbot feature that has been improved basically to allow you to go into the data and ask a question. So you're going to see this next to tabular data files, this little chatbot. When you come to the file page to use that chatbot, it's going to have an open window for you to ask a question. It's going to see the tabular data, but it's clueless about the data. It's cool. Now, this chatbot is going to be able to, put your question in here, ask a question, and you're going to get some feedback about the question that you asked. The LLM is going to kick in and give you some information about the data based on your question. Okay. So this is just a broad slide of examples of file support in the Harvard Dataverse. We have the image graph again about files belonging in a data set, computational workflow, folder hierarchy support. There's file level provenance support. These are the file level access controls that you're going to have options to use. And then the supported file formats for tabular data support. These are things to consider way before you bring your data in, what you're going to use, okay? Coming soon, support for big data. So this is just a general slide to give you an idea of what we have available. There's direct upload and download to S3. Globus is being completed for transfer to F3, and there's remote data in remote stores for sensitive data. Please keep in mind that the Harvard repository does not support sensitive data yet. Your data are expected to be de-identified and cleaned, regardless if it's restricted, regardless if it's embargoed. It must be cleaned because we check for data that we think might be sensitive. And if there's sensitive content, your content will be de-accessioned until it's clean and made available for reuse. This is just an image of the Globus transfer to Dataverse and how it works with the Globus endpoint, the Globus service, and where it's managed, and the different storage options that would be available for Globus. We do have large projects coming in, so these are all things that we've been considering. So just considerations for large data are going to be storage costs. Make sure that if you have a very large project that you contact us ahead of time about what those costs might be. There's an initial data transfer cost, file access costs, file size limitations, account limitations, access protocol backups, and usage monitoring and admin overhead to consider. We are, of course, looking for free options as well to offer for large data storage. All right. Now we're going on to permissions and access. So after you decide on a number of metadata and file upload options that are available for you, you need to think about or know about the permissions and access and what the flexible permission options are for your files. So Dataverse supports multiple workflows by controlling who can deposit files on your behalf and who can download files once they've been restricted. You have roles that are defined, and what you get is custom. You can add custom terms, you can restrict data, but you must clearly always define terms of access when you restrict data. And there's a request access workflow. And you can see all of those here. So just moving my notes out of the way for 1 second without losing them. This is the permission page for granting access to users at the file level, on the files. You can grant access to all the data sets in a file by giving dataset level access. They will get access to all your files, but you can also control which files you want to give access to a user for. This is what restricted files look like on our page. And as you can see, here's the request access option that's been used. You're going to see examples of custom terms that people use. So they don't want you to use the request access. They might want you to fill out an application or send more information to their team before they give you access. So again, as I mentioned, the access is public, restricted, embargoed, and then you have embargoed, then public. Just to show you where the labels show up when you have embargoed content, it shows up on the page of the data set. It also shows up by the file, which what's embargoed. Licenses and custom terms. We have a list of licenses that will support your data sharing for restricted files. If you do restrict files, this window is going to automatically pop up, and it's going to ask you to either enable the access request or to add the terms. That's the information about what somebody needs to do in order to access your files. If a repository finds files that are restricted, without any terms. First of all, it shouldn't happen because this is enabled as a function. But if they do, your data doesn't meet fair. Your data can't be shared that way. If restricted access has to have information about why it's restricted, if it's embargoed for how long, or how someone can request access. And here's an example of what it will tell you once you fill it out, that there's one restricted file in this data set, and in this case, users may request access using that request access feature that I showed you previously. So as I mentioned, permissions for file access to the files, because metadata is always visible. But to actually get data set, the files, you can give permission at the data set level by assigning a permission. Somebody creates an account, you give them permission, request access, they actually go in and request access with their account. You're going to see a page in the back that has the information to either grant or reject access. At the file level, that means you're picking which files you want to give somebody access to. And there are a lot of data sets that have multiple files, and some people can have access to more, restricted files than others. So you get to decide who you can give access, who gets access to which files. One of the ways to share your data set, if you have content that may not be restricted, but you're not ready to share yet, is a private URL. This only works for draft data sets. So when you have a data set in draft, you can select private URL and enable that link and send it off to people who you need to just come in and look at your data set without your data set being published. Your collaborators, maybe a journal wants to see that you've deposited content and you have a DOI. That's how you would share your draft data set without publishing it. The other feature that's available is called the anonymous peer review. And so this, of course, is for anonymized data that you want to share. So like the private URL, and I've included the GitHub ticket to conversations around that because the Harvard Dataverse Repository instance hasn't enabled it, but Borealis's group has. You can do a unpublished dataset private URL anonymized dataset link that you would send for review. You send that off and they'll come in and they won't see who you are, what where you're from, and you'll be able to share your dataset in that view. So now we're going to move it on to Amber, who's going to talk about enhanced file handling of data types. And I'm going to navigate for you, Amber.
Thanks, Sonia. Yeah, so Dataverse has many features that support enhanced management of certain file types and formats. Next slide.
Yep.
So file handling features include enhanced deposit and sharing features, including file identification, checksums, file preservation, and normalization. I'm going to talk about tabular data ingest for tabular formats, which includes metadata extraction and normalization of these formats. I'm going to talk a little bit about geospatial data handling and preview, as well as additional file metadata extraction and file previewers for exploration and data analysis. Next slide. So this checklist provides an overview of the Dataverse file handling and management features for certain common data formats. There are some limitations with certain formats. Not all data sets or formats are created equal, and Dataverse promotes the use of open data formats as much as possible. And for certain files, it does provide conversion and normalization into more open and stable formats, as well as the ability to explore and preview these types of formats and integrate it with analysis tools. Next slide. So with file preservation, what we're talking about here there are clearly risks associated with format and media obsolescence already being encountered by researchers and data archives. The inability to read file formats in old software or old media is a major challenge faced in the digital age. So format identification is the process of determining specific formats or types of a computer file based on its contents or file extension. Dataverse uses the MIME type label, which is used to identify the type of data. It is used so that way the software can know how to handle the data. The Dataverse MIME type is based on the international registry called Pronom. A checksum is a value that represents the number of bits in a transmission to the system and is used by the Dataverse system to detect changes and any errors with that initial transmission. The default checksum algorithm used in Dataverse is an MD5 checksum. File normalization is an archiving procedure that identifies and targets particular file formats and converts them to this identified file format that is considered open and less vulnerable to change over time. Dataverse has built-in format normalization for tabular data formats, described in more detail next. Sonia talked about file metadata and how it's important and how it's structured for use with files in Dataverse. And file metadata can be uploaded, created, and exported in JSON or XML format. Sonia also mentioned folder preservation, including upload of zip and compressed formats that contain folders and hierarchy that are required for preservation, and this is supported in Dataverse. There's additional exporting options for preservation system integrations, including export of Baget format using OAI APIs. Next slide. So more on tabular data ingest. So certain file formats, including Stata, SPSS, R, Excel, CSV, and TSV, may be ingested as tabular data. Tabular data files can be further explored and manipulated with external tools. And so commercial applications such as SPSS and Stata use their own proprietary formats to encode their files. Reading these specially formatted files requires some extra knowledge or special software. And for these reasons, they're not considered ideal purposes for archival preservation. The Dataverse installation stores the raw data content and extracts from the files and converts it to a plain text tab delimited file format. The metadata that describes the contents of the file are stored separately in Dataverse in a relational database so that it can be accessed efficiently by the application. This metadata contains variable metadata that conforms to the DDI metadata standard, a structured metadata schema for describing the contents or variables of a data file. There are many reuse and integrations possible with this tabular data ingest, including enhanced variable metadata tools, previewer tools, exploration and analysis tools, and sharing of the data in both the original format or the tab delimited text format or in R. Next slide. So preparing and formatting your tabular data before deposit is really important. Ensuring you have clean data that is correctly labeled, including variable names, definitions, category labels, value labels that are all well documented is essential for deposit and sharing in Dataverse. So some important tips here showcased on the slide, including, just so you all know, it is possible that you will get ingest errors sometimes, and these are often caused by things such as improper formatting. If you have multiple tabs in a spreadsheet, it won't be accepted. Sometimes you need to ensure that you are encoding the data correctly using the appropriate language, and you can do this by clicking on the advanced options and selecting the language from the list provided in the ingest. And I'll just highlight that it's always good to keep your responses and observations as rows and your variables and concepts as columns. Next slide. So the next thing I want to highlight for you is about variable metadata. Let me see my notes. Where did this go? Here we go. So I mentioned that Dataverse stores variable metadata that is extracted from these tabular data formats during ingest as DDI variable metadata. So Dataverse supports DDI codebook version 2.5. And a DDI codebook is really a structured set of metadata facilitating the production of a machine-readable codebook or data dictionary. It's built to emulate a physical codebook describing the structure of a dataset, its variables, codes, values, summary frequencies, and more. And you can see in the slide is an example of a codebook generated by Dataverse using the variable metadata extracted from the tabular data formats. Next slide. So I want to talk a bit about geospatial data. Dataverse supports enhanced management of geospatial and scientific data formats such as shapefile and GeoJSON, and it includes integrated previewers. A shapefile is a set of files often uploaded, transferred in a zip format. This set may contain up to 15 files, a minimum of 3 specific files, .shp, .shx and .dbf are needed to be a valid shapefile. And the fourth file, a PRJ file, is required for preview or any type of meaningful visualization. And this is a projection file format. GeoJSON is an open standard format for encoding geographic data using JSON and must contain two types of fields, including a type field, including non-spatial features, and coordinates, including projection information. Coordinates can be defined using EPSG codes, which is an international standard for coordinate system and geospatial projection information. Next slide. And a map will be shown as a preview of the GeoJSON file when the previewer has been enabled. Next slide. So NetCDF and HDF5 are open, platform-agnostic scientific data formats used in climatology, meteorology, oceanography, and can be used in common GIS tools. For NetCDF and HDF5, an attempt will be made to extract metadata in the XML format and save it to Dataverse as an auxiliary file. Then the NetCDF and HDF5 files can be explored and visualized with H5 Web, which has been adapted to be built as a previewer for Dataverse. And you can see the screenshot here is showing you the HF5 Web visualization and preview tool. Passing it over to Gustavo.
Yes. Hi, everyone. So I will next discuss the file versioning and how we deal with that within Dataverse. So to discuss versioning for file, it makes sense first to understand exactly how versioning works for dataset. Generally, a dataset, you'll create it, it'll be an unpublished draft, and when you publish it, it becomes version 1.0. At that point, as you work on future versions and future drafts and you publish them, they will either be minor versions, such as 1.1, or a major version, 2.0. And in fact, Dataverse requires you to have a major version if you have added or deleted a file. And within these dataset versions, the things that relates to files that can change, the file metadata can be changed for a version. So for example, if the file is exactly the same file, but you need to change its name or its description or its path, you saw earlier the tree structure, for example, then that would happen just as file metadata being changed from dataset version to dataset version and is tracked as part of the versioning changes of a dataset. And additionally, what we have as file versioning, and I put it in quotes because really what it is file replacement. Unlike the dataset versioning where you're changing bits and pieces of the version, for file versioning, you're actually replacing the entire file. And this is important because that way the previous file still exists exactly as needed in case someone is doing replication with an older version of your data set. So the way this works is you go through the file replacement functionality and you upload the new version of the file and it gets linked to the previous version. And on the right, you see an image of where you can see under the edit options for a file to replace it. Next slide, please. And so one thing that we provide in Dataverse as well is persistent identifiers. As you probably already know, persistent identifiers are assigned for every data set, but we have added the ability to have persistent identifiers also for individual files. This is something that is configurable at an installation level. So with some installations will have it turned on, some will have it turned off. And as we've learned as a use case at Harvard, we didn't necessarily want to have it on for every data set and within Dataverse. So we actually have recently added, I think in 5.14, the ability to configure in an installation that only specific Dataverse collections have file PIDs. So in this case, the ones that need PIDs can have it, the ones that don't need it. And in defining a persistent identifier file, there are two ways they can be defined. They can be defined as dependent or independent. And that just generally means that, if you see on the right, on the bottom, you see a dataset citation and it ends in BLXV. And so if it's a dependent PID for the file, then you'll see that the file persistent identifier on top is the same as the dataset with an additional random string afterwards. Some people think this is useful because that way it shows a connection to the dataset. All the files will have the same, basically, first part of the persistent identifier matching with the dataset. Others think that persistent identifier should be completely agnostic of any identifying information, and so would prefer the independent way. And in the independent way, which we don't have an example here, but basically the persistent identifier is completely random compared to the data set. And so there's no connection seen within the identifier itself. Next slide, please. From here, we'll talk a little bit about files and external tools. We've already seen a lot about different external tools in the parts that Sonia and Amber presented. So I'll just give a little more holistic view on external tools and go through some other examples. So the basic idea is external tools provide additional features that are not part of the Dataverse software itself. We've seen, for example, some previews. We'll see more detail when Amber gives her demo on visualization, and also for curation, for example. And they work with Dataverse via its APIs. And so any tool that wants to and can talk to Dataverse APIs can be written and registered within Dataverse. There are tools that can be defined for datasets and for files. And I'll talk a little bit about both here. And then they can be either read-only or read-write. And we'll talk a little bit about both those scenarios. And on the right, just you can see the list of the contents in the API guide that talks about the inventory of external tools and how to manage and test and writing your own external tool. Next slide, please. So I mentioned how once you have an external tool, it gets registered within an installation. And so here we see an example of a manifest file. Any tool that you want to be visible within the Dataverse software would need a manifest file, and you upload it to data via its installation. And the manifest basically just contains things like the name, a description, more importantly, the type of tool, whether it's an explore tool or configure tool, or as we add these new kinds of tools like the ask the data tool, which we'll talk about a little bit again, and Sonia referred to earlier. It contains the URL, so it knows where to go for that tool and the parameters that the tool needs. Different tools will need different things. Some might just need the file. Other tools, for example, dataset level, we need the dataset ID, or other subsets, sometimes specific variable information if it's a tool that deals with specific variables. Next slide, please. So the basic tool that we've seen a lot of already is the different file previewers. And there's a bunch of different file previewers. They allow you to see the contents of files without having to download the files separately. You can basically see it within Dataverse itself. And here's a list. I won't go through the entire list, but you can see we have previewers for lots of different things, for audio, for video, for PDFs, for text files, for tabular, et cetera, et cetera. You've seen some examples already of the GeoJSON and the NICMO files. And the way they work within Dataverse, you can see on the right, in the top image, there's an eye icon, and that allows you to, that's on the dataset page. And if you click on that, it will open up the preview in the data file page, which is what you see below embedded as the preview tab on the file page. Next slide, please. Here's just a couple other examples of different file previewers. The previous page had the image. Here we see the preview of a PDF on the left, and on the right, we see the preview of a tabular file. And one thing I'll note is you'll notice on the right, instead of the tab saying preview, it actually says file tools. And the reason is because in addition to preview tools for tabular files, we also have this type of tool called the explore tools, which I'll talk about in a minute. And so when you're on the preview tab for the file, you also have access to all these extra exploration tools under that files tools dropdown. Next slide, please. So the last previewer that I'll discuss is zip file previewer. It basically shows you the internal contents and structure of a zip file. It also works on electronic lab notebooks. And the reason I think it's interesting is because you see, I call it File Previewer Plus, because it's not just a previewer. It also can individually unpack the zip file and download individual files. So if you're interested in just some part of the content of a zip file, you don't have to download the entire thing. You can view the file previewer version, and there's a way to select which files you want and download those. You can see on the right the download icon for downloading individual files. Next slide, please. So in addition to the previewer tools, I mentioned there were explore tools. And so the file level explore tools really provide a variety of features from visualization and statistical analysis. We're going to do a little bit of a deep dive with Amber into the Data Explorer tool, so I won't really talk much more about the explore tools. There's also, and earlier when I mentioned there was read-only versus read-write, the explore tools are an example of read-only tools. They are able to read Dataverse dataset files, but they don't write anything back to Dataverse. The configure tools are those that are read-write. And so you have to obviously have the right permissions, but if you're authorized to edit a Dataverse dataset, then you're able to use a configure tool to basically send additional metadata back into Dataverse about the files. On the right, we see an image of the data curation tool, which is a tool that was created, in fact, by Borealis in order to be able to expand on the variable metadata, change the labels, the descriptions as necessary from what is originally ingested during the ingest process. And the last and the most recent type of tool that was added, and Sonia referred to it when she was talking about the AI integration, is this query tool type tool. And it's really an experimental new feature. It's to allow the user to ask questions in natural language using LLM models about the contents of the data file. And I saw that there was already a question in the question and answer on whether this is available just in Harvard Dataverse or every installation. And the answer is any installation can do it. The infrastructure for supporting this query type tool is in the core code. And there is a separate GitHub repository for the ACID data repository. The one note I'll make is that you need to have your own key for OpenAI when you set it up. But if you have your own key and you can set up your own version of the ACID data tool, then you can have it run in any installation. Next slide, please. And so those previously we discussed those tools that are defined at the file level. We also have tools that are defined at the data set level. And so these basically allow you to explore all the files of the data set in conjunction. It's usually used for reproducibility. A couple examples of those are Wholetail and Binder. On the right, you see where you can access Binder through the Access Dataset drop down on the data set, and below is when I went earlier and just clicked on it, and it opened up a Jupyter notebook of a data set that I was looking at in Binder so that I could further, operate and explore it. We also have just recently in our develop branch, it'll be released in the next version of Dataverse, allowed the ability to have configure level tools at data set. So again, you need to have the proper permissions to be able to edit the data set, but if you do, it can basically work on a data set as a whole. And we're doing this in conjunction with work from ICPSR on a tool that's coming soon once we have this released and once their tool is ready, called Turbo Curator. And the idea is that's going to provide recommendations on the metadata, which will help improve the process and is a way to review the metadata through one of these external tools. Next slide, please. On to Amber.
Great. So we wanted to showcase one of these Data Explorer tools. And so the tool we chose was Data Explorer, which is really built for tabular data formats, or in this case, I'm going to demonstrate survey data analysis using Data Explorer. Just so you all know, Data Explorer 2.0 has been released openly on GitHub, and you can configure your Dataverse installation to use this. And this was contributed by Borealis. Next slide. So data analysis using Data Explorer has many features, but overall, it really helps users to understand your data, to explore the data online without having to download it and use proprietary software. So you can preview data and metadata for variables, questions, notes, universes, all these variable metadata that are attached to the data sets themselves. So you can get started with data analysis, you can do digging, filtering, look at summary statistics, and so on. And you can also build frequency charts. You can also do multivariate analysis using cross tabulations. And from the Data Explorer, you can also subset variables of interest and download them. Analyzing data in Data Explorer really promotes this idea of data reuse of your data, as well as transparency and reproducibility of data results, as well as teaching data concepts, things like ordinal and nominal variables. And overall, it just promotes more open access and sharing of your tabular data. Next slide. So connecting to Data Explorer, so after you've ingested your tabular data format, you would click on the tab file and you would use the drop-down icon to navigate to the Data Explorer tool. Next slide. From here, a new window will open, which is the Data Explorer connected application. And this window will showcase all the features of Data Explorer, including if you've grouped variables, you can see and navigate different variables by their group. On the very left side of my screen, you can browse by variable groups to view only those variables associated with certain topics, for example. You can search for variables within this tool in the search box icon directly to the left of the variable groups, or to the right. And you can also select multiple variables at one time. If you would like to preview all of them in a summary statistics window, you can do that. And so in the top right, there are options for cross-tabulating 2 or more variables, viewing summary statistics or multiple summary statistics, as well as subsetting and download. And to view summary statistics of a single variable, you could use the options in the line item for that particular variable. Next slide. So here's an example of a selection of multiple variables, and then a preview window shows up with the summary frequencies, as well as the weighted counts, weighted percentage counts. And if you scroll down in this window, there's summary statistics provided as well. Next slide. For cross tabulations, I mentioned you can do some multivariate analysis, so adding certain variables to the rows and to the columns to create this cross tabulation table that you see here. Next slide. And then as well, you can select only certain variables that you're interested in subsetting, and then download those as a tab delimited file. You can also download the original file format from this tool and in our format. And we also provide the variable metadata, which is required if you are going to use the tab delimited format. Next slide. And so some further integrations that we're looking in for this tool include the ability to weight cross tabulations, or the option to weight the results of the cross tabulation, as well as some more interactivity with those charts and visualizations, perhaps exporting them into a data format would be nice. And then as well, we are always working closely with the team at Harvard to ensure that there's enhanced support for the data documentation initiative and that variable metadata. But overall, you can use the Dataverse APIs to build your own data exploration tools, as Gustavo was alluding to. And so this has been really helpful to us. We've been able to provide this type of integration in Borealis. And Data Explorer is a completely open and ready to use tool that you can install with any installation across the world. And it's really flexible, and it allows for you to integrate it into search sites or data catalogs. So I've provided the example here of how we've embedded this tool into Odyssey, which is a Canadian social science data archive, and all of the files, all of the metadata are stored in Dataverse. Passing it over to Sonia.
Figure out how to unmute myself, put myself back on video. So thank you very much. We have time for questions. What we've included here for you are some resources to our guides, our support website for the Harvard repository, since we spoke a lot about that today. We also have our training page with upcoming webinars that will focus on very specific details of the Dataverse software and what it offers. So we have a metadata webinar coming up. I believe that's next. We'll have one on intermediate curation soon. We'll have more on APIs. So check out our upcoming calendar and contact us anytime with additional questions. I will stop and see if anybody does have any questions they would like to ask. You can raise your hand. You can unmute if that allows you to. You can. I'll actually unmute folks, and if you have any questions, we have time for a conversation. I think I've unmuted everyone. Well, okay then. No questions. You know how to reach us. Thank you very much. We will send off a survey that we always appreciate the feedback on the survey for the information we provide. We're always available to demonstrate for groups, put together personal demos and trainings for groups. So you can reach out to us with those requests as well. So we hope that this was helpful. Thank you very much for attending.
Thank you, everyone.